Okay, what if I told you that the future of medicine is actually being written right now in a vineyard? I know, it sounds a little out there, but stick with me. We're about to dive into this really powerful idea that's changing how we see the future. And it all kicks off with one single, surprisingly tricky question.
So here it is. How many grapes are in this vineyard? Now, for a winemaker, this isn't just some fun riddle. Nope. It's a multi-million-dollar gamble they have to take every single year. I mean, think about it. Your entire business, everything from who you hire to how you ship your wine, it all hinges on getting this prediction right. If you get it wrong, well, you're looking at a massive financial hit. For decades, this has just been an expensive, super frustrating guessing game.
So the old way of doing this? You'd literally send people out to painstakingly count grape clusters by hand, but only in a few small sections. Then you just kind of guess and hope your extrapolation was close. It was slow, it was wildly expensive, and honestly, it was a total shot in the dark. But the new method? Wow, it's a whole different ballgame. We're talking drones with 3D cameras and AI scanning the entire vineyard. It's automated, it's scalable, and the results? Well, they're just staggering.
Check out that number, 99.58%. That is the prediction accuracy researchers got. Let that sink in. We went from a hopeful guess to nearly perfect foresight. And that huge leap in accuracy, it wasn't just because we got better cameras. It was because we found a fundamentally better way of thinking about the problem itself.
And this, right here, is where the story gets really interesting. Because that genius solution for counting grapes, turns out it's not just about grapes at all. It's actually a perfect case study for a super powerful strategy that's now being used to solve some of the world's most complex problems. And it has a name: comparative modeling.
So what is it? Well, think of it like this. Let's say you're trying to build the fastest car in the world. You wouldn't just grab the first engine you find and call it a day, right? Of course not. You'd test a bunch of different engines, you'd compare how they all perform, and then you'd pick the absolute best one. That's all comparative modeling is. It's just applying that same rigorous, common-sense logic to solve really complex problems, whether we're talking about agriculture or artificial intelligence.
And the core strategy is really simple, but so powerful. First, you identify the problem. You define the challenge with absolute clarity, like predict a harvest. Then you compare the models. You put the different solutions head to head, like a showdown between the old manual count and the new AI scan. And finally, you just choose the best fit. You let the data decide the winner. It sounds so obvious when you lay it out like that, but believe me, this way of thinking is fueling a revolution.
So what's really driving this big shift? Well, it's a move away from systems that run on fixed, rigid rules, and a move towards systems that can actually learn from data and adapt in real time. This isn't just a small change. This is the fundamental leap from the industrial age to the information age playing out right in front of us.
You can really think of it as two different worlds. The old way, it was like a train on a track. Super powerful, super efficient, sure, but it could only go where the track was already laid. It basically assumed the world was stable and predictable. But the new way? It's much more like a self-driving car. It learns the patterns of the road, it adapts to new routes on the fly, and it responds to unexpected stuff. It doesn't just survive in the chaos and complexity of the real world, it thrives in it.
And the thing is, the old way was hitting a brick wall. It was just too slow, too expensive, and honestly too fragile to keep up with the modern world. I mean, a system that's built on yesterday's rules has no chance of defending against tomorrow's cyber attack, right? It can't navigate a road it's never seen before. It was pretty clear we needed something smarter. We needed something that could learn.
And that's exactly what we're getting. So, where else is this new, adaptive approach popping up? Well, the answer is pretty much everywhere. It's quietly transforming the world all around us. Let's run through a few really powerful examples.
All right, take your car's cruise control. Think about the difference between a brand new driver and a real expert. The new driver is just rigidly following the rules, right? But the expert, they feel the road. They're adapting to changing conditions, making these tiny split-second adjustments. That's the difference we're talking about. These new systems learn from experience, which makes them way safer and way more responsive. Or how about cybersecurity? The old method was kind of like a security guard with a list of photos of known bad guys. If your face wasn't on the list, you could just walk right in. But the new AI systems, they're more like seasoned detectives. They take the time to learn the normal behavior of a network so they can spot anything that seems out of place, even if it's a brand new threat they've never seen before. And in that world, that's the difference between being one step behind the hackers and being one step ahead.
Even governments are getting in on this to write better policy. Instead of just guessing what might work, nations are now comparing their different AI strategies. They're looking at what's working in other countries and, just as importantly, what's not. By learning from each other's successes and failures, they can build smarter, more effective policies for all of us.
But you know, maybe the most profound impact of this whole new way of thinking is in healthcare. Because here, we're not just talking about improving efficiency or making better predictions, we're talking about saving lives.
Okay, let's bring this all home. Remember, we started in a vineyard, asking a simple question about grapes. But the exact same logic, that idea of comparing models to find the one that sees the world most clearly, is now being used to ask a much, much bigger question. Can we predict the future of our own health?
And this quote, it just says it all. The great shift isn't just about replacing old tools with new ones. It's about moving from systems that follow rigid instructions to systems that learn and adapt. The real revolution isn't just about faster computers or more data. It's a fundamental change in how we approach problems, from building systems that just follow orders to creating systems that can actually learn.
And there's no place where the power of this shift is more clear than in the fight against cancer. I mean, researchers set out to see if they could use this exact approach to monitor a cancer patient's condition in real time and do it with a level of accuracy that honestly was previously unimaginable.
Okay, look at this. A standard machine learning model, already an incredible 97% accurate. A deep learning model was right there with it. But when they compared those to a brand new hybrid model, one that combined a digital twin of the patient with a deep learning algorithm, the results were just breathtaking. The accuracy jumped to 99.73%. And that tiny little percentage point might not sound like much, but it is everything. It's the difference between uncertainty and confidence, between reacting to a problem and predicting it before it happens. It's a world of difference.
And so, this is where we're left. This new science is giving us an almost unbelievable power to see what's coming, from the next grape harvest all the way to the changes in our own bodies. The future is becoming more predictable than it has ever been. But with that incredible clarity comes a really profound responsibility. So the question we have to ask ourselves is no longer just, can we see what's ahead? The real question is, what are we going to do with that knowledge?